Our exam is next Thursday. All right, so 10.3, 10.4. So we'll finish 10.3, hopefully, is the plan, and start 10.4. We better, we're in trouble. All right, so we're doing the egg shapes. Ellipse is an egg shape. Last time we did the parabolas, right, which were U shapes. We go up or down, or right or left. Parabolas. Those are the hardest. So the good news is this will be 10.3, 10.4 a little easier. They're not a lot easier, but they are a little easier. You still have to worry about the four directions, which is hard for parabolas. So this is a little bit easier, not a lot, but I think you'll find this a little bit easier. Then I think 10.2 is probably like the hardest section in the course. All right, so egg shapes. You know the name of the game is always the format of the equation. You know, that's kind of like what we're always doing in this chapter. Remember, for ellipses, we're in ellipses. For parabolas, it was y squared is plus or minus 4ax, or x squared is plus or minus 4ay. Remember how we always tried to give the parabolas that look? You know, if they started out looking funny, then we would do what I call plastic surgery. We'd try to remove the wrinkles, make it look different without being different, until it looked like that or looked like that, right? Why did we do that? Because then we knew how to graph from there and how to find the focus points and anything else they wanted. We knew how to deal with the thing once we made it look like that, right? That was how we handled that last section. Well, it's going to be the same thing in this section. It's just a different look. Let me give you the look. So the goal, the look that we're going for is x squared over a squared plus y squared over b squared equals 1. It's all going to be about getting a 1 on the right side. Different. The parabola, we wanted to get a 4. We forced a 4. Even if there wasn't a 4, we would make there be a 4 over on the right side. But now it's going to be all about getting a 1. So most of this section, the game we're going to be playing is they'll give us a picture or they'll give us a messed up equation, and we'll work with it until we can make it look like x squared over a squared plus y squared over b squared equals 1. Because once we have it in this look, we can get everything we need from it. That's how these sections work. I hope you're getting the big idea. That's how all these graphing ones work. You've got like a goal that you want to make it look like. That's why 3x5 card, really helpful for this section, because that you can put all the little details on there. All right, so here we go. So how does this thing work? What do? Well, it's like I said, it's a little easier than the last one. Whatever's underneath x is always right, left. X is always right, left. So whatever's underneath x, that's how far right and left on the graph. So I don't know, can you see that little graph? How far right, like the edge, to the edge. So this edge point right here, where is it at? Looks like 3 to me. And this edge point looks like -3. So that's right and left 3. So what does that mean? That means this will be x squared over 3 squared. If you made -3 squared, that would be the same thing. It's still going to be 9 either way. So I'll just say 3 squared. Everybody okay with that so far? And then whatever's underneath y, that's up, down. So how far up and how far down? Looks like it's up 2, down 2. So that's going to be 2 squared. So x squared over 9 is b, isn't it? Y squared over 4 equals 1. So there's our first one. Yes?
We left off on number 9 in this section.
Oh, we did?
Yeah.
Oh.
You really have to say that?
Like I'm enjoying the review. All right.
I don't remember anything.
Well, thanks for that. I forgot all about that. Okay. Even now, I don't remember at all. It's gone from my mind. But all right. So I'm glad to hear that. I'll move ahead a little bit. All right. So you guys are like, we got this, Mr. Heron. All right. So let's try this one. So I've already got the vertices there for you. So they want you to find the vertices and the foci. Remember how this works? Let me draw a quick picture. So whatever's underneath x, that's always right, left. So 49, that's 7 squared, and 16 is 4 squared. That's the look. We have to make it a number squared, right? So 7 squared, that means it's right 7, back 7. That's how we get the vertices. 7, 0, and -7, 0. See how I give that answer? And then whatever's underneath y is 4. So that means it's up 4 and down 4. So this must be 0, 4, 0, -4. Like that. Here is the egg shape, the ellipse. Now, where are the focus points? What I mean is, are the focus points up, down, or are they right, left?
Right, left.
Correct. How do you know?
Because it goes lengthwise.
Yeah, it's always the bigger direction, huh? Yeah, if the thing is wider, then the focus points go sideways. If it's taller, they go up, down. So the focus points always go the bigger direction. They always do that. Yeah, good, good. So the focus point must be like here and here. Did I show then, since I have done stuff which I don't remember at all, did I show like a string and how you would draw? I did that? Okay, yeah. So you know that the focus points are like two nails, and what we draw here is like what you would do with a string. If you had a string attached and you drew from the two focus points, right? That's what an ellipse is the set of all points that have the same total distance from the two focus points. Like a string has one total distance. Yeah, that's how the focus points generate the ellipse. Anyway, so we don't need to do anything with that. But yeah, so the focus points are always on what we call the major axis. Did I use that word? This would be the major axis, which just means the bigger one. So this one, it's sideways. All right, so what? Well, that means the focus points are right and left. How do we find the actual focus points? What's the equation for finding focus points?
Is that c squared equals a squared minus?
So you're not lying to me. Yeah, we've done this. I wouldn't assume you know that unless you've done this. Yeah, right. That's it. So let's write it. Yep, the focus is like the Pythagorean with a minus, isn't it? It's a squared minus b squared is c squared. So it's the Pythagorean with a minus. So yeah, now let's be clear on what A, B, and C are. A, B, and C are how far from the center to the edge or to the focus point. A and B are to the edge, C is to the focus point. Is that making sense what A, B, and C are? That's different than the last section. In the last section, A represented how far to the focus point, didn't it? Now we're changing the meanings of the letters in this section. So that's why this is hard. Important to put it on your 3x5 card to keep all those little letters and things straight. So again, A and B. What are A and B? It means how far from the center all the way over to here. That's A. And then backward, same thing. And what's B? B's how far up to the other edge. So A and B are how far from the center to the edge. Well, what's C? How far from the center to the focus? That's C. So A and B are center to edge. C is center to focus. Okay? So what? And the other thing is when you're subtracting two things, got to put the bigger one first, don't you? So here's the... yeah, let me just leave it at that. So so this is 7, and this is 4. So 7 goes first, 4 comes next. So that's 49 minus 16. Is that 33? So c squared root it, plus or minus. C is plus or minus root 33. Too quick? Everybody see what I did there? Just took 7 squared minus 4 squared. So C is plus or minus root 33. What does that mean then? The C is, the focus point is here and here. That means right plus root 33, comma 0, comma minus root 33, comma 0. Right? That's those two focus points. That's this point right here and this point right here. And we're done. That's all they want. All is well? All right. Okay, I will do 5 quickly. Because it's kind of a weird one. X squared plus y squared is 36. All right. Remember what we got to do. We got to give it a look. What look do we want? X squared over a squared plus y squared over b squared is 1. That's the goal. That's the look. We got to do plastic surgery until it looks like this. Right? All right. So what do we do first to this one to start moving towards this look? To make it look like this. Yeah, because you got to get a 1 on the right side. It's all about getting 1 on the right side. So if you have some number on the right side that's not 1, then you need to divide through by that. So divide by 36. And that puts a 1 over there. And then this is 6 squared. 6 squared, right? That's the look. You make the bottom number squared. All right. We gave it the look it needs. So now we can graph it. So when we go to graph it, center's at 0, 0. And then whatever's underneath x, that's right, left. So I go right 6, left 6. This is 6, 0, minus 6, 0. And then whatever's underneath y, that's how far to the edge, up, down. So that's over 0, up 6, over 0, down 6. And so then I draw my egg shape, but it's a perfect egg shape. perfect egg shape. What does that mean, perfect egg shape? It's a circle, isn't it? Circle is a special case of ellipse. It's like a perfect ellipse, kind of like a square is a perfect rectangle, right? So this one's actually a circle because the width and the height are the same. It's a perfect egg. I don't know if that's a perfect egg, but whatever. It's a circle. So what are the coordinates of the vertices? The weird thing on this one is they want you to list all four. That's totally abnormal. This is really strange because all four of them are vertice points. Normally it's only the two in the biggest direction are vertices, right? That's what we've been saying. If it's wider, you always have four edge points, but you only call the vertices the biggest edge points. Are you tracking with me on that? So, but this is weird because they're all the same distance. So we list all four. See how I listed all four in the vertices? And now let's find the focus points. How do you find the focus points? What's the equation for focus? Pythagorean with a minus. So what's a squared and b squared? 6 squared and 6 squared. C squared is 0. Root it. What's the square root of 0? What's plus or minus 0? 0. 0. So where's the focus points? Right there at the center. The two focus points became 1, didn't they? Two focus points became 1 because it's a circle. It is a circle and the two became 1. If you guys in the back could just whisper so the people around you don't get distracted, please. So 0 on that. And so this is a totally weird one. So the focus point is just, why did I say 7? What's that? I don't know what I'm doing there. But the coordinates of the focus point is 0, 0. That's it, just 0, 0. We're done. So that's a weird one. Let's move on quick from there. That good? Just okay. So let's try this one. Center 0, 0, vertex 0, 7. Center 0, 0, vertex 0, 7. B is 3. Graph the thing. Write the equation. All right, let me give you a minute to try that. I would start with writing the equation. You know what I mean? X squared over a squared plus y squared over b squared is 1. Now, remember when I say A and B, these could be swapped. Is that making sense? It doesn't have to be A underneath X. A could be over here. Well, how do you know which is which? Think right, left, up, down. That's what you want to think. So don't rely on A and B and say, oh, A is always what's underneath X. That's not true. A could be over there underneath Y. So don't count on that. What do you count on? Right, left. X is always right, left. Whatever's underneath X is how far to the edge right and left. Whatever's underneath Y is how far to the edge up and down. So what's this? That's 7. That's here. Huh. Because it's under Y. Even though I'm calling it B, it's not this B, is it? So what must this be? This must be the other one. The A and B are swapped here. How did I know that? Because up, it was up 7. That's got to be underneath Y, whatever you call it, A, B, or Joe. Whatever you call it, if it's under Y, it's how far up and down to the edge. Does that make sense? So that's what you want to rely on. That's why you always want to draw part of the graph as you work with the equation. Because that's what will clue you into what goes where. So one more time. I started drawing the picture. I put the dot and I noticed, oh, it's going up 7 to the edge, to the vertex. That's the edge, right? It's going up 7. Meaning that this egg, well, do we know right now? Is this egg shape taller or wider? Or do we even know? We know it's taller than it is wide. I don't know exactly how much, but that just helps me kind of get going. I would just draw that just to kind of get going. You know it's taller than it is wide. How do you know? They didn't tell me how wide. Or actually they did, huh? Well, they told me 3, but how do I know that's width? How do I know it's taller than wider? Because vertices are always the major axis. They're always the bigger direction. When they called this by the name vertex, they're saying that's the bigger way. That's what they're saying. So you need to know that. When they use the word vertex, they mean the bigger direction. We're saying this is the bigger direction. The other edge points, they won't call vertices. I don't know what they call them. They just call them edge points, I guess. But they're not called vertices. The vertices are uniquely given to the longer direction, the major axis. So when they called this a vertex, I thought, oh, you're saying it's taller than it is wide. Right. That's what they're saying. Okay, and then this is up 7, which means it's under y. And so then this is the other one, so this must be the one underneath x. Even though they call it b, whatever, a and b are interchangeable. It's the other one, so it's got to be 3 squared. So that's it. We're done. They want the equation. There's the equation. Is that okay? So always be drawing the graph as you're writing the equation, because the up-down goes underneath y, the right-left underneath x. All right, I'll move on if you're okay. All right, so let's start with this one. So they want us to find everything, pretty much. They want the center, the focus, the vertices, and the graph. So, everything. So start with the picture. Start with the picture. Start with a graph. And the first thing you should put on the graph is the center. Do you guys know what the center of this egg shape, this ellipse, is going to be? Yeah. It's always, for all these graphs, it's always opposite of whatever number's next to x and y in the parentheses. So the center is going to be positive 1, negative 4, over 1, down 4. A little bigger. We good? Over 1, down 4 for the center. Is that making sense? Now, let me. A lot of what you want to do is compare. Let me go back and show you a difference. See how? Well, not that one. See how in this one, when I got done, there was nothing next to x in the parentheses. Nothing. That's why the center was 0, 0, huh? Because there was. This is the last or 2 problems ago. See how there was no number next to x in the parentheses. So that's the same thing as x minus 0 squared, isn't it? That's the same thing as y minus 0 squared. So that's why the center is 0, 0. So when there's no number added or subtracted next to x or y, that means they're 0, really. And the center is 0, 0. Okay. So looking at this one, the center is 1, negative 4. Put that right on the graph first off, and that's what they want here is the center 1, negative 4. They want the center. We got that. Okay. Now, I would start graphing it. Can you take the next step in graphing? Do you know how far right and left? How far right and left do we go first off? Where do we find that? Under x, and that's 7 squared. This one's 2 squared. Huh? Yeah, look underneath x. Whatever number squared is under x, that's how far right and left from the center. What is it? It's 7. And it's under x, again, so it's right, left. Whether you call it A or B or Joe or whatever you call it, doesn't matter. It's under x, so it's right, left. So it's right 7, left 7. And what's underneath y is 2, up 2, down 2. So is this one taller or wider? Wider, because x is bigger. So see whatever number's bigger under the x or no y, that tells you which direction is the major axis. So anyway, how do we find? They want the coordinates. Let me show you the easiest way to get those coordinates. You just add 7 and subtract 7 to the x coordinate of the center. Right? Because that's from the center, isn't it? That's from the center, right 7. From the center, left 7. So add 7. So 1 plus 7, that's going to be over here 8, negative 4. And then subtract 7. 1 minus 7 be negative 6. -4. And those are the vertices. The up-down are not going to be the vertices. They're going to be just edge points. But these are the vertices because they're the major edge points. Yeah? Yeah, good question. The 1, -4, that's the center dot. So it's from the center. So when we say, hey, we're going, underneath x is 7 squared, right, left 7, it's right and left 7 from the center. So I want to go to the right 7, and I want to go to the left 7 from the center dot. So that means I want to add 7 and subtract 7 from the x-coordinate of the center. Right, left. Good. Yeah?
On our homework, it's saying vertex right of the center. Is that what you're doing right now?
Yeah.
Okay.
Yeah, this would be the vertex right of the center. Exactly.
And that's left.
And this one's the vertex left of the center. Exactly. Good. Okay, so that's the right, left. Now let's find the up, down. Can you guys do it? Let me let you do that real quick. I think you get more out of it if I let you try first. So get the up, down edge points. You're going to look underneath y, right? And do the same thing. You've got to mess with the center. So I'm going to take the center, and so you know what it's going to be, right? It's going to be up to and down to from the center, isn't it? Because y, what's underneath y? 2 squared. So what does that mean I'm going to do? I'm going to take the coordinates of the center, and I'm going to add 2 and subtract 2 to the y-coordinate this time, because we're having an up-down effect. I'm not messing with the x-coordinate. Now it's just the y-coordinate, because it's up-down. So if you take -4 and add 2, what is that? What is that dot right here? It's going to be 1, -2. And then if you subtract 2, that's going to be 1, -6. And now we can draw. Mine looks terrible, but anyway. Draw our shape. Everybody see how I got those 2 coordinates? So what I did is I took the -4. It's all about the center. Notice the center leads to everything. It's the root of the whole tree, right? So I start with that center, that 1, -4. And when I go right, left, I add and subtract 7 to the x-coordinate. When I go up, down, I add and subtract 2. That's what's underneath y, 2 squared, to the y-coordinate. So -4 plus 2 gave me that -2. And -4 minus 2 gave me the -6. And the x-coordinate doesn't change when you're going up and down. Yeah. Is that good? We've almost got everything. Last thing is the focus points, the foci. They're always, now, are the focus points going to be right, left of the center or up, down from the center? Right, left, because they're always in the major axis direction. Focus points always lie in the bigger direction. So that means they're going to be somewhere on this line, aren't they? Which means I'm going to take the center again, the root of the whole tree. I'm going to take the center again. I'm going to mess with the x-coordinate. So I'm going to go right and left from the center again, this time to find the focus points. Now, how do you first find the focus points? You know the equation. A squared minus b squared is c squared. The Pythagorean with the minus. Good. So can you do that? Can you find C? How do you know what a squared and b squared are? It's the numbers underneath x and y. And remember, don't get hung up on a is always x or b is always y. Those are interchangeable. It's bigger. They're subtracted. So when you subtract 2 things, you got to have the bigger one first. So which 7 squared or 2 squared, which one's bigger? 7 squared. Good on that? And so that's 49 minus 4, 45 is c squared. Root it up and down the ladder. So c is plus or minus root 45. Yeah, so we got to reduce that a little bit. You guys good with how that works? Remember, that's 5 times 9. Square root of 9 is 3. So that's going to be plus or minus 3 root 5. We good? You remember that from algebra? So I just square rooted the 9 to be 3. So plus or minus 3 root 5. Okay, now what do I do with that plus or minus 3 root 5? I go back to the center. Remember, it's all about the center. He's the root of everything. And I'm going to... Am I going to mess with the x coordinate or the y coordinate? X, because the focus points are right and left on this one, because the major axis goes sideways. So I'm going to add 3 root 5, and I'm going to subtract 3 root 5. And you can't really add them or subtract them because they're unlike terms. So that means you just write, I'm going to write right here, 1 plus 3 root 5, comma negative 4. And the other one, 1 minus 3 root 5, comma negative 4. Done. Those are the two focus points. And we're done. Is that okay? Did y'all see how I did that last one? Why can't I add these? Remember from algebra, they're not like terms. You can't make that 4 root 5. If it was 1 root 5 and 3 root 5, then you could add them. But it's not. It's a plain 1 and a 3 root 5. So they just stay that way. We're just done. Is that okay? Does everybody see how I found those focus points? So notice how it's all about the center on these, isn't it? From the center, I've added and subtracted 7, because 7 squared was underneath x. To the x coordinate. From the center, the y coordinate, I added and subtracted 2 to the y coordinate, because 2 squared was underneath y. And then from the center, I added and subtracted the focus distance, 3 root 5, because that was right and left, so I did it on the x coordinate. It's all about that center. Questions I can answer on that one? All right. This looks awful. It is awful. So this one, a lot of the battle in math and science is recognition of things. It really is. I want to really help you with that. That's always kind of one of my major goals. And because I know how you can look at an exam and they can all look alike and you're not sure what to do. A lot of what you want to try to do, I'm not just making stuff up. Education studies, those who study education and get their doctorates and all that, and they write articles and all that. Education studies consistently show that people that are successful in math and science, also foreign languages, I don't know why that lumps in there too, but I guess same kind of thinking, they have their thoughts organized in different categories. They think more that way. So that's what you want to try to do more and more to help yourself digest this material. So I'm trying to help you along that same line. So as you look at this, this has got to fit in a certain category in your mind. What about it? What marks? What's on the file that when you see this on the exam, there will be one of these on the exam. You'll see it and you go, oh, I see certain marks. That means it's this file. Grab that file and do the steps there. Hey, what's unique? We did it back in the parabola, but I know you forgot everything over spring break, right? So I know I did. I didn't even know we'd done 9 questions in this section. But anyway, did anybody remember? There's a certain mark which says we need to complete the square here. Yeah. Good, Chinu, that's it. When you see x squared and regular x, or y squared and regular y, that's when you go, oh, complete the square, meaning middle term over 2, quantity squared, that whole thing. Got to do this. So let me write some of this out now. This is really a hard one. So here's the mark first off. When you have x squared and x to the first, or y squared and y to the first, when you have both, both those, then you must complete the square, this whole process. Now, how does that work? Well, we did it for the parabola. This is going to be all that was and more, unfortunately. This is going to be even harder. Step 1, you must factor out the number in the front of x squared and y squared. The number in the front. What am I talking about? That 25 right there. By the way, remember what our goal is? Yeah, maybe I should let's keep the goal before us. What is our goal? Our goal is to do a bunch of plastic surgery to give it this look. Actually, you know what? Let me give it more the real goal. The real goal is more like this: x minus h squared, y minus k squared. Like that. That's our goal. That's where we're headed. We want to do plastic surgery, remove the wrinkles on this thing, and it's awfully wrinkly. It's a long way from the look we want. We want to make it look like that. Right? Why? Because once we have that, we know how to handle it. We know how to graph it and find everything. Right? You with me on that? See this game we play? It's the same game in all these graphing sections. It's what they always do in math and science. It's a lot of math and science. It's plastic surgery. Take something messy, give it the look you need, then you can do what you need to do with it. So, I got to give it that look. How are you going to do that? First off, factor out the number in front. So I'm going to take out the 25 that's in front of x squared. Oh, you know what? Actually, let me reorganize it first. This is a hard one. Glad we're doing this. This is the worst of it. 25x squared plus 250x, leave a little space, plus 36y squared minus 432. 1021, jump it to the other side. All right, there's my first step. See how I gathered up like things? X squared, x stuff together, y stuff together, number on the right side of it. Like that? That's good so far. Now, take out this 25 and take out this 36. That's what I'm saying here. Factor out. There's what I'm saying. How we doing? Did you enjoy a week off from this mess? We dived right back into a big messy one here. All right, so when I factor out, how do I know what number goes here? What goes right here? Yeah, 10x, huh? Because what? Because if you distribute it, it would go back to 250x, wouldn't it? Remember, we're making it look different without being different. It's got to really be the same. Is everybody good with that so far? And then what number needs to be here? 36 times what will go back to minus 432y? I have no idea. How are we going to find it? Divide by 36. Take your calculator and take that 432 and divide it by 36, right? Because you're asking 36 times what will be 432? So when you're asking a times question, you got to divide. That'll tell you what multiplies, huh? So if you divide, is it 12? Did I hear you guys say 12?
Yes.
12? And it's minus 12y. Are we good so far? We did not, back in the parabola last section, we didn't have to factor the numbers out. They didn't put numbers on the x squared and the y squared. This one's a little harder. Good so far. So right now, if I was to distribute this, it would go back to the same, wouldn't it? If I was to distribute this, it's the same. It just looks different. Okay, now, how do we find what I call the magic number? How do we find the number that will complete it? Let's square the middle number. Yeah, exactly. That's step 2. Middle number over 2 squared. Added to both sides.
Now that's different from the parabola where it was just divide by 2, correct?
Same thing. Over 2, divide by 2.
2 power as well.
Right.
Okay.
Both of them, you got to divide by 2, then 2 power. Yep, both of them, yeah. So that means I've got to take this 10, put it over 2, and square it. Got to take this minus 12, put it over 2, and square it. Is that making sense? So let me write it over here where we have room. 10 over 2 squared, that's 5 squared, 25. And negative 12 over 2 squared, negative 6 squared, positive. It's always positive, huh? Because you square them in the end. So middle number squared. Okay, now what do you do with that? You add it to both sides, huh? So here I'm going to add 25. And here I'm going to add 36. But I've also got to add to the right side, right? This is a equal sign, left side, right side. Got to keep the balance. So far, so good, though. I'm going to add to the right side in a minute. But so far, so good. Why are we doing this again? Because look at this now. See how that'll factor beautifully now? That's x plus 5 quantity squared, isn't it? See how that gave it just what it needed to factor? So we're moving towards that look. We're almost there. We made it parentheses squared, didn't we? By adding that number. See what that number completes it. Like the old saying, your spouse completes you. Gives it just what it needs to factor as a parentheses square. Completes it. Just what it needed, right? This one also, look at the y one now. How's that one going to factor? Y minus 6 quantity squared, huh? Yeah, see how that was perfect? That's what that completing square number is, that middle number over 2 squared. That's what it does. It makes it factor as a parentheses square, as a square, completes the square. Okay, now we can't change the problem though. That's the issue. We're removing the wrinkles. It's the same person. We can't change the problem. Just the way it looks is all we're changing. So whatever I do to one side, I have to do the same exact thing to the other side. Otherwise, I've made it a different problem. What did I really do to the left side? I put a 25 right here. Yeah, I did.
And you multiply it by 25.
Yeah, I put a 25, but notice I put it in parentheses. Thus, it's under the influence of another 25. I really added to the left side whatever 25 times 25 is. 625. Do you see that? I've got to really add 625 to the right side. And what do I got to do for this one? Whatever 36 times 36 is. 1296? Is that what it is? I've done these problems. I can't really do that in my head. I've done these problems a million times.
It's a trick.
No. 20 years of teaching these problems. 1296. Okay. So is that good? Now I want to make sure that I know that looks weird what I just did there. If you were to distribute out this, did everybody see why I had to do that? I didn't have to do that back. It's because of this stinking 25 in the front there. If there was no number in the front, I would say, look, I added 25 to the right side, just add 25 to the other side, no big deal. 25, 25. But the problem is there was another 25 here. So meaning if I distributed this, there would be a brand spanking new 625 really. By sticking that new 25 in there under the influence of another 25, I really increased the left side by 625. 25 times 25, didn't I? So I have to really increase the right side by 625. Do you see that? Okay. So that's a tricky step. I know this is complex stuff. You could put one of these whole things on your 3x5 card. I mean, it's a lot of room, but it's one of the hardest things. All right, so let's see. So now we can factor. This is x plus 5 squared. This is y minus 6 squared. What's the right side? I don't know. Whatever. You guys have a calculator? I don't know what that is. What does all this come out to be? Is it 900? Nice.
No. Oh, is it really?
I'm taking Jeffrey's word for it. Is that what it is? 900? Great. All right. Good so far. We're almost to this look. We're close. We got those parentheses squares now. We completed the square. What do we got to do now? What's more is required in that look? Divide by because you got to make 1 on the right side, huh? So whenever you have a number on the right side that's not 1, divide through by that 9. Now that you got the parentheses square thing going on, just make a 1 on the right side and you're basically there. So divide through by 900, 900, 900. So 25 into 900. What's that in the calculator? 36, huh? And 36 and 900, I bet that's 25 because that's the opposite one. So there it is. So we have x plus 5 squared over 6 squared. Y minus 6 squared over 5 squared equals 1. We gave it the look. Now we can begin the graphing work.
Is it always going to be that way? The number that's in front of it, is it going to be the number that's in
Swap?
front? Yeah.
No.
It's not always.
Won't
gonna be
always. No. So everybody see what happened there, though, at the end? I divided through by 900 to make a 1. We always have to get a 1 on the right side. That's going to be for the next section also. So it's kind of consistent now. Always got to do 1. So I divide through by 900, and then I just use my calculator. 900 divided by 25, 36. 900 divided by 36, 25. And there. Now you could graph it, right? You could find the center. Do all. I'm going to just go dot, dot, dot. We don't have time to do it, so I'll just go dot, dot, dot. Now it's got the right. All that's preliminary work. All that is laying the foundations. Now you pour the concrete, right? That was a lot of setup work. Now you can find the center. What's the center of this thing? Yeah, opposite, opposite. -5, +6. That'd be the center. Right and left, because 6 from that center. Up and down 5 from that center. You know, you could do all the rest.
How many of these are?
Yeah, these are long, huh? I don't, 20, 25, something like that. I mean, oh no, of these particular ones, one.
What are these?
Yeah, just one of these. It's good. I mean, it's awful, but are you okay with it? All right, practice. I mean, this is why I say I had to give my life to math and science in my junior college years, and 8 years of my life were swallowed up sitting around doing this. This is what it takes. So you got to do this 2 or 3 or 4 times. You know, I would see this in class when I was a student, and I would be very confused. I would go home, and I would take my notes, and I would try doing it until I could get the answers the teacher was getting. So that's... All right, so now this is like a test question, multiple choice, not like what we're used to seeing. So go ahead and try that one. So they're wanting us to go backwards. They're giving us some information. They want the equation. What's going to help you is the picture, right? So be drawing the picture as you're coming up with the equation. That'll help you. Start drawing that graph. Good, get that much of the graph? Couple of vertex points, got a focus point. Is this, draw what you can. Does this thing go more up, down, or more right, left? Up, down, because the vertice points are up. Wherever they are, that's the longest edges, huh? Remember that? Whenever they say this is a vertex, that means this is the longest direction. So I'll just draw something like this. I don't know exactly how wide or how... But good enough. Just something to help me begin thinking about it. The vertices are the edges, right? Something kind of like that. Good so far. That helps me come up with the equation. Now, what's the next thing you really need to find on this one? The center. Yeah, you really have to find the center. Can you do that? Find that center. It's got to be right in the middle of those two vertices, doesn't it? Remember how we find the middle of two numbers? If you got a 70 and a 90 on 2 exams, how would you find the middle? You would add them and divide by 2. We call that averaging, huh? So find the middle of those two vertex points. Now, you don't need to mess with the -2. But you need to mess with the 8 and the -4. Right? We know it's back 2. The back 2 is no question. It's somewhere on this line, back 2, isn't it? But how far up or down? Well, you got the center of 8 and -4, right? 8 and -4. This vertex is up 8. This one is down -4. See how I'm just grabbing the y coordinates, not the x, because I know the center is back to something. Right? So what do? You add and divide by 2. You average them. It's the average. So 8 plus -4 divided by 2, that's 4 over 2, 2. So there it is. There's the center. Back 2 up 2. 2 is the middle of -4 and 8. Right? It's 6 away from that guy, and it's 6 away from that guy, isn't it? See how it's the very center? All right, now can you write the equation? See what you can do. Now that you have a lot of pictures, you should be able to start writing some of the equation. So it helps me. You know, I took a million math science classes, and a lot of times I would read crazy questions. I didn't have any idea what to, especially physics. Physics was very hard. And I would read them, and I'd just go, I don't have any idea what to do. And I'd stare at the problem for a while, and I noticed a pattern in my life. As I stared at problems, nothing good ever happened. But as I started saying, all right, well, at least I know it's supposed to be kind of like this. Just take a step. Write something down that you know. And things will start flowing. Not always, and a lot of times I still couldn't do it, but a lot of times I'd be surprised, like, oh yeah, actually I do know this next step, and then next step, and things would sometimes start connecting. So just write something down. If you have no idea at all, just say, well, look, I know it's got to be something like that. How about that? Do it, and then go, what's next? Do it, what needs to go up there with x and y in the parentheses? Do you know that? Yeah, pluses and minuses. How do you know what they are? They're always the opposite of the center here, huh? Opposite and opposite, because this is the center point, isn't it? Whatever goes next to x and y is the opposite of the center numbers, isn't it? So, okay, so we know that. That's got to be x plus 2 and y minus 2. Good so far? We know that much. Which means we can actually eliminate B and D, huh? Because they have the signs wrong. We're halfway there. We good to there so far? Now, can we come up with the A and the B? That's all we got left to do, right? It's find A and B. How do we find A and B? What are A? Did everybody see that last step? I just took the opposite of -2. That's +2 for x. And the opposite of the y coordinate, opposite of +2, is -2 for y. So now, what is A and B? What are they? Are you clear on what they even are? They're how far to the edge from the center. So, how far from here up to there? 6. Isn't that 6? From 2 to 8. That's 6. From the center to the edge. That's 6. Now, is that 6 squared under x, or is that 6 squared under y? How do you know? Because it's up and down. You with me on that? Anything up, down has got to be underneath y. Don't get hung up on A and B. Just don't worry about it. A and B are just, they're interchangeable. It's just, hey, if you're up, down, you're under y. If you're right, left, you're under x. So that's up 6, isn't it? That's up 6. So I go, okay, so that's got to be 6 there. Good. I still don't know A. Now, what's A? Well, that's how far to the right. I don't know that. I have no idea. Nothing yet can help me out with that. Is everybody good to this point? Am I losing you? Making sense? Now, how am I going to find the A? Focus equation, huh? Now it's time for the focus equation. Yeah, let me come up here and do the focus equation. So focus equation, you know that's a squared minus b squared is c squared. All right, so a squared minus, do I know b squared? B squared, 6 squared, equals what? Now what's c? What do you think about c? Yeah, good. Remember, A and B are how far from the center to the edge and edge. C is how far from the center to the focus point. Remember what A, B, and C are? A and B are how far from center to edge, sideways or up and down. C is how far from center to focus point. Yeah, how far is it from negative 2, 2 to negative 2, 4? It's 2. C is 2. Is that good? That's what. Are we clear on what A, B, and C are? We'll do a lot of these with A, B, and C, and it's even in the next section as well. We'll have an A, B, and C same thing. So be clear on that. So A and B are how far from the center to the edges of the egg shape. C is how far from center to focus point. So that's 2. All right, we ready? So we're going to solve this now. We good? We good to hear so far? Are we good? Are we happy? Because it's totally wrong, and nobody's noticing. I feel like I could do whatever I want to do up here. Pretty much. Funny being a math teacher sometimes. Yes, good job, Jeffrey. I've got the A and the 6 in the wrong spot. How do you know? There's so many details here, isn't it? Why? Why are the A and the 6 switched? The 6 has to go here. It has to go in the front. And the other one, whatever you want to call it A, call it B, call it Joe, whatever, it has to go in that order. It'll make a difference in the final answer. Why? How do you know?
Would it make it negative?
It'll make it negative, but why? Why is it negative? What are we doing that's weird and wrong? What have I said? Whenever you subtract two things, who has to come first? The bigger. Well, how do you know which one's bigger? Look at the picture. That's why we're drawing the picture while we're doing the. You've got to have the picture. Don't try to do this without the picture. You tell me, look at that picture. Is it up, down, bigger? Yeah. Up and down is bigger, which means what? The number under Y. The 6 is the bigger, which means the 6 has to come first. Yeah, but the other one's A. Remember, don't get hung up on that. That could be B. Those are interchangeable. Am I communicating clearly on that? I don't want you to get hung up. MathXL describes it in a totally weird way. Here's another one, Matthew. You said, I have an issue with MathXL and that financial one. I have an issue with MathXL here too. Then if you click on the help button, I didn't realize they did that until a few years ago. I worked with a student, and they were having all kinds of trouble with A and the B, and I'm like, don't worry about all that. They're like, well, look, Mr. Aaron, and they showed me the MathXL, and I couldn't believe what MathXL did. They said it's A if it's this, but if it's B, if it's that. And we have enough to worry about. Just when you're subtracting two things, the bigger one comes first. That'll handle it. That'll handle it. So, but don't get hung up. Don't think, well, A is always underneath X. No, not necessarily. They're interchangeable. Well, let me just leave it at that. They're interchangeable. So, yeah, but this is A, and you're calling this B. Yeah, whatever. They're interchangeable. It means the other one. And how do I know what order? This thing is taller. Look at the picture. It's taller than it is wide. So the one underneath Y is the bigger. So that has to come first. Okay, now it'll work. So 36 minus b squared is 4, right? Now we can solve this thing. Subtract 36 from both sides. So minus b squared is minus 32. Get rid of the negative. B squared is 32. So b is the root of 32, you know. So anyway, b squared is 32. That's it right there. That's the 32, right? You know, square root of 32 squared, if that helps you. Whatever. It's 32. So it's A. It's answer A. Everybody good there?
After we cross out B and D, what did we just say since the Y has the vertices 36 is a bigger number.
Yeah, good job. Yeah. So a good question is, hey, do we really need to do all that focus stuff you just did, Mr. Aaron? We'd already got rid of B and D, and we're down to A and C, and we knew 36. X squared was under Y, so it had to be A. True for this problem. But remember the mean thing that I do on my tests. None of the above. So how would you know whether it's none of the above? A could be wrong. I'm not just trying to be cruel. I'm trying to get you ready for calculus. Calculus makes this look like easy. Maybe that's a little dramatic. Not easy, but calculus is a bigger step up. So I want you. So you got to really be able to solve the whole thing.
Is that 5A?
5A. 5A. Yeah, it's a big step up. Yeah. C between. Yeah, good question. C. So everybody covered A, B, C. Let me say that one more time. A and B are how far? So let me draw it again. So A and B are how far from the middle to the edge, and it doesn't matter whether you call it A or B. It's just whatever. And then C is how far from the middle to the focus, which is 2. Because they gave me the focus is -2, 4. The center is -2, 2. From 2 to 4 is 2. Does that make sense? A and B are from center to edge. C is center to focus. On that'll be for the next section as well, which we'll start today and finish Thursday. So just know that'll go a lot of mileage for you out of that. A and B are center to edge. C is center to focus on that. Is that good? So we did solve for everything, although it took a long time.
Do you teach calculus?
These are long. Comfortable, more and more comfortable with these. All right, let's try that one. So draw that one. The picture is so important. So draw this out. Give me a good picture. Draw this thing. I'm glad to help. I'll wander around. You know how I can help? It's all about a good picture and remember what A, B, and C are. They want the equation. All they want is the equation, but the graph will really help us come up with the equation. Feel free to talk with those around you. You guys are such a quiet group. Feel free to talk it out, help each other out. Compare and contrast as much as you can out of this time. Draw that picture. Gotta find the center, right? Center's really important. So first find that center. I would find the center first.
The bigger one. Like the biggest thing is maybe 16.
Just find those dots.
Like 8 the other way. I'm assuming. I mean, like that's half the distance.
The first number is over.
And there is 2 and negative 4.
I'm trying to do that.
The first number is over. So
There's 2 focuses.
So get the dots on the graph first off.
So that's adding up and dividing by 2. 2,
4. We have a third and a fourth exam, and then the final.
So 3 of them.
Counting the final, yeah.
Not counting this one, right?
So we've had 2. We have a third exam and a fourth exam and a final.
Oh, this, oh.
Do we have to take the final or is it?
Yeah, it's required. Okay, good so far. So we got those 2. Those are 2 focus points, huh? I think it would be helpful just to draw the general egg shape right now, just to get something to look at, even though we don't know everything yet. Generally, is the egg shape more up and down or sideways? It's sideways because the focus points are always on the major axis, aren't they? So in general, it's going to go something like this, isn't it? Good so far? And the focus points are always inside. They're not the edges. You with me? That's an important observation. Focus points are inside for all the graphs we do. Vertices are the edges. Focus points are inside. Focus points are always inside. They're not the edges. Right? So how do we find the center? Add and divide by 2. Add what? Well, the two numbers are different. Not the negative 4s, right? They're both negative 4. Not the negative 4s. That's the same. But the negative 2 and the 6. You with me? The negative 2 and the 6, you want to add them and divide by 2. You want to find the middle of the negative 2 and the 6. So the center, maybe I'll do it over here. Over 2, 2. So that would be right here. The center is 2, negative 4. So I came up with that? 2, negative 4. Because I took the negative 2 and the 6. Took this negative 2 and the 6. I add them and divide by 2 because the center is going to be right in the middle of the two focus points. Good. Now we need to find basically the equation. Can we start writing the equation? You kind of, what you do, notice you kind of do some of the picture, write some of the equation. Do some more of the picture, write some more of the equation. You kind of keep those together. The picture helps the equation. So what can I write right now for the equation? Yeah, you can do opposite for the center. Put that in the parentheses for x and y for the equation. Right, so we're talking opposite. So that would be minus 2 plus 4. Good so far? And then we have a squared and b squared. They could be swapped, though. Remember, a and b are interchangeable. Don't get hung up on the a and the b. Yeah, now what we have is we have to figure out the edges. Because that's what a and b are, aren't they? A is how far over to there. Right? That's what A is. A is from the center to the edge. B is from the center to the edge, up and down. Good. That's always what A and B are. They're from the center to the edge. C is from the center to the focus point, isn't it? That's C. Everybody see what A, B, and C are? Getting the hang of those? A and B are from the center to the edge. C is center to focus point. Do we know any of those?
Well, the length of the axis is 16.
Yeah, they told us the length of the major is 16. So how far is it from the middle to the edge if the whole thing is 16?
8.
It's got to be 8. A's got to be 8. Everybody see that?
Wouldn't you add 8 to the 2?
If I had to find it. Nobody's asking me to find that coordinates. They're just saying they want the equation. But you're right. Yeah, I mean, if you wanted to actually find this point, you would add 8 to the x-coordinates. That'd be 10, negative 4. You're right.
But they're not asking.
They're not asking. I don't want to do more than I need to do. Yeah, does that make sense? So the 8, because the major axis is 16, that means all the way across to 16. From, it's like all the way across the circle, like diameter, but they just want halfway radius. Right? Get the idea? A is just from the middle to A is just halfway. Like a radius instead of a diameter. The major axis is 16. The width is 16 all the way across, so it's 8 from the middle to the edge. Okay, now how can I find the b, the y? How far up? I have no idea how far up.
A squared minus B squared.
Focus equation, yeah. Can you use the focus equation? So use the focus equation.
C squared is the center.
It's from the center to the focus, right?
Yeah, see right here in the picture? C is how far from the center to the focus. That's always what C is. Starting to make some sense. A and B are how far to the edge. From the center to the edge. See how A, see what they are in the picture there?
4 squared, right?
A is how far from the center to the edge. Sideways. B is how far up to the edge. C is how far to the focus point. From the center to the focus point. So can we see what C is? Can you tell what C is just by looking at it? C goes from 2 to 6. C's 4. C's 4. Center to edge, right? You getting the hang of what these letters are? That's a lot of the battles, getting used to what they are. C is always center to focus point. So, in the focus equation, a squared minus b squared is c squared. The c is 4. Now I know either, is that a or b? Again, don't just assume. Ask yourself, when you're subtracting two things, the bigger one has to come first. The bigger one has to come first. Which of those is the bigger one? Is it bigger sideways on the picture? Yeah, it is. So whatever's underneath x has to be the bigger one. So 8 squared comes first. Does that make sense? If it was taller, then I would put whatever comes underneath y first in the subtraction. 8 squared would have been at the back in that case. If it was taller than it is y. Does everybody see that? So again, when you use the focus equation, they're subtracted. So you got to put the bigger one first. How do you know which is bigger? You look at the picture. If it's wider, then the bigger is whatever's underneath x. X is wider. If it's taller, then the bigger is whatever's underneath y. That would go first. That's how you know. All right, now we can solve for b. This is 64 minus b squared is 16. Subtract 64. What is that? Minus b squared is minus, is that 48? 48, so b squared is 48. So root it. So b is the root of 48. So b squared then is the root of 48 squared. So you could just say it's 48, huh? And this one's 64. It's 8 squared.
Simplify that then at all.
Yeah, you don't have to. Yeah, you can just write it that way.
There's no plus or minus in this one?
It's squared, so it'll be positive in the end. Yeah, it is plus or minus, you're right. But since it's squared, it all comes out
You
positive
just
in the end.
put the 48 there.
Yeah, I just put the 48. Are we good? Is it getting any better? Getting more comfortable?
When you write the equation on that, that's all, it can't say 8 squared, right? It has to say.
I think you could say 8 squared. I think they'll take that. I think they take it either way. Yeah, I heard somebody else tell me they did when they were typing it in. Either way. Either way.
On the test.
Multiple choice, so. All right, I'll move on. You okay? All right, let's try that one. Center and vertex contains the point. Wanted to show you one of the contains the point ones. So center 0, -2, vertex 5, -2 contains the point. Try that one. You need a picture, right? It's always about a good picture. So there's the center, over 0, down 2. We have a vertex over 5, 2, 3, 4, 5. That's a vertex over 5, down 2. Now, what does that tell me as soon as I know there's a vertex? Oh, let me do the point. Over 0, up 1, there's a point.
So that has to be on the outside of the egg.
Yeah, so point means it's on the edge of the egg. Exactly. Right? And do I know, is this one more wide or tall? Wide, because the vertex is to the right. So, sort of like that, right? We good so far? Oh, this will be a snap. I thought it would be more tricky. Can you do it from there? Oh, I know. It sounds like it's inside, huh? Yeah, contain point means on the edge. Yeah, it doesn't mean like it's inside. It sounds like inside. Yeah, contains mean, hey, we got it. It's in here, right? No. Yeah, in math, they always mean it's on the edge of the graph. Yeah. No, they use the contain word differently in math. It's like I contained the animal. It's in the fence. What I did before I left on vacation for spring break is fixed my backyard fence so my dogs wouldn't run away, as much as I would hope they would run away. My wife and daughter are sad. Still haven't lost that dog. We had the young man, he was watching our animals. I told him I would increase his pay if the dogs got away while we were gone. But it didn't work out. They're still there. All right, so write the equation. X squared over a squared, y squared over b squared is 1. Oh yeah, we got to do the center thing, right? The center, the opposite is 0 and the opposite in a2, so that's going to be y plus 2, isn't it? Like that. Yeah, is that enough to do it right there? Well, it's a or b, huh? It's a or b at this point.
Oh, yeah.
Yeah, a or b. Yeah, C and D are out, aren't they? C and D are out because they have the wrong sign on the Y, don't they? Good so far? And then how far is it to the right? Well, it's 5. And where does that go? It's underneath X because it's right.
Oh,
So it is A. Yeah. And how far up? How far is that? This is over 0, up 1. That's, yeah, it's up. This is, it helps to put in marks here. Down 1, down 2. This is 1, 2, 3. It's up 3. That's 3 squared. But we're done. We got it. Yep. It's A. Is that okay? Everybody see how I found it? So again, what are A and B? A and B are how far from the center to the edge, aren't they? A and B are how far from the center to the edge. And C, we didn't have to mess around with C on this one. C would be how far to the focus points, but we didn't even bother with those. Is that okay? Does everybody see that? Right? 5 over to there, 3 up. No, I didn't write 3. 3 straight up. 3 straight up. Like that. We good? All is well? All right, let's move on. Okay. A bridge is built in the shape of a semi-elliptical arch. So they're building a bridge like an ellipse shape. Okay, so what I'm going to do is I'm going to do analytic geometry. Remember how we talked about that? That means I'm going to make up an axis system because that makes the geometry easier. This is why we put algebra together with geometry. It's like putting words to music, right? Because it goes better together. We put algebra to geometry. It's called analytic geometry. It means there's axis systems and it helps us. So I'm going to make up an axis system that's not really there. And I'm going to have this bridge that's like an ellipse bridge. But I'm going to put it in the middle of an axis system. That's why engineers do that, because it makes the numbers easier, the geometry easier to do when you put it on a made-up axis system. Okay, that's how math works in the real world, right? We make it up. That axis system is made up. It's not really there to help us do things that are real. All right, so semi-elliptical. Okay, soon as I write that right there, let's start with my equation. You always need the equation, huh? The equation is going to be x squared over a squared plus y squared over b squared equals 1. Good so far? Let me give a warning. I do all I can to help, but I have a lot of students. There's one word problem on the side. Bless you. There's one word problem of either from the parabola, the ellipse, or the hyperbola. Yeah. There's one of these chapter 10 word problems on the real exam. I don't even remember which one. I made it up 6 months ago. So there's one of them. There's one word problem on there. So maybe one like this, maybe one of the other ones. I don't know. Maybe one of them focus points in the parabola thing. Anyway, watch the words though. Really, really, watch those words. I've had a lot of students. I mean a lot. Like out of a class of 40, maybe typically 10, a fourth, will do this. They'll somehow not see that phrase, I guess, because you won't know what section you're in. They're all mixed up. And they'll write y squared is 4ax. They'll write the parabola equation and start doing a bunch of work with the parabola equation. It's just 0 from the beginning. They started, it always surprises me. I'm like, it says ellipse right there. Right there, it says ellipse. We got to use an ellipse equation. I know it's confusing. We've had them all and all that kind of stuff. But watch out for the words. They'll tell you. They won't beat around the bush. Right? In the last section, we did some parabola bridges. Now we're doing some ellipse bridges. So they'll tell you what it is. Use the right equation. So when it says ellipse bridge, we're going to use the ellipse equation, not the parabola. And all right, so here we go. We're going to use the ellipse equation. What's the center? Well, it's 0, 0. I just did that because it was easy. Great. So I don't have to mess around with anything subtracted or added with x or y. Okay. Now, what do they tell me about the bridge? It spans 160 feet. Max height is 20. So this is up at 20. The span's 160. So how far right and left? 80 here. Back 80 there. Does that make sense? Span 160. Height 20. Good so far? So do I know the a and the b in the equation? What's a have to be? 80 squared. Y is 20. Because remember a and b. A is how far from the center over. B is how far from the center up. Huh? That's pretty easy. Good so far? This one's going better than I thought. Now we're ready. I thought there'd be more to it. This one. Okay, now that axis system really helps. Now we're ready to answer the actual question. That is the equation. We've got the equation at this point, don't we? Now we're ready to answer the question. What's the question? Find the height 20 feet from the center. So that means if you go over 20 feet, how much clearance is there going to be? They would want to do this, if they had lanes for cars and trucks to drive, they want to know how much vertical clearance they have. 20 feet, the engineers who would design it would want to know what the clearance is. So they're saying when you're over 20, what's the y-coordinate? That's what they're really saying. Do you see that? They're asking, what's this dot contained on the edge of the ellipse? When x is 20, when you're 20 feet from the center, what's the y clearance up to the ellipse? So how do I figure that out? Just plug it in. Just plug it in. X is 20, y is y. So literally just plug it in. So this will be 20 squared over 80 squared plus y squared over 20 squared is 1, and solve for y. Does that make sense? I put 20 in there, and y is just y. How we doing? Just making sense? So I found the equation, and now I'm trying to find a point on the edge of the shape. Remember, all the points that are on a graph make the equation true, don't they? That's why I'm able to plug it in. All right, let's solve this thing. If you solve this thing, I'm kind of running out of room here. 20 squared, you get 400 over 6,400 plus y squared over 400 is 1. If you divide that in your calculator, isn't it 19.125. I think. Is that right? No, I might have that wrong.
0.065.
Thank you. Yeah, I was doing 1/8. Thank you. 0.0125? 0.0625? Thank you. Everybody good to there so far? Kind of scribbly. So I'm trying to solve for y. So I'm going to subtract 0.0625 from both sides. Bring it over here. We've got y squared over 400 is, what's that, 0.9375. Good there, I just subtracted. I just took 1 minus 0.0625, became 0.9375. And then multiply both sides by 400. I need a calculator.
I think it's 375, I think.
Oh yeah, nice. 375, and then root it. Good to there. Root it, whatever that is. Yeah, 19.36, huh? I don't know how far they went around it. They said 2 decimal places. Yeah, 19.36. So it's 19.36 feet high. So I would tell them if they're getting the clearance they need for where they put the lanes for the cars or the boats or whatever it is. Trains, whatever. So that makes sense how we did that. So we came up with the equation by using a made-up axis system and a picture. And then we just plugged in the point over 20 up y. That's not too bad, right?
Midterms?
That's easier than some of those other ones. Yeah, it says round to 2 places, so it's about 1936. The decimal actually went on. 1936, 49, blah, 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 blah. That's why we're saying about, because it's not exactly 19.36. All right. Have you had it with that?